Hey, you 11s. Just in case you're doing the revision sheet and you're finding it confusing to do question 9, 10, and 11 from the 2018 SAC revision, I'm going to show you how this question is done and what you're meant to really think about when you're doing it, in case the solutions didn't make sense to you. Okay, there's a lot of there are two ways to do this, and I'm going to try to get you to think about triangles and rotating it to get what you want. Okay, so what we want to start off understanding is, in this particular problem here, this is the region where the angle's in. Okay, it is between pi and 3 pi and 2. So if I actually draw the unit circle and I ask myself, all right, where would pi to 3 pi and 2 roughly be? Well, this is pi, 3 and pi and 2 is here. So that means the angle, okay, so the angle that it makes goes around the circle to that point, somewhere in between, it's lying between pi and 3 pi and 2. Okay, that's the angle. Now within that angle, I've now landed on a particular spot between pi and 3 pi and 2. Okay, so that spot I've just colored in with a dot. And what you're trying to find is, what is the angle if I know I want to find the cos of that angle? Now remember, cos represents which values? It represents your x values. So at this point, I'm actually looking for this value on the x-axis. I want to know how long it is. That's what I'm looking for. Now I'm going to call this A. Okay, this is the length of A. I'm going to color it in green. Everywhere that I draw in green, it means the length of A. Okay, but what I want you to see is I've got a triangle here, which I'll highlight. This is my triangle. Okay, and I'll draw that in a wider sense out here. I'm going to just draw the triangle a bit wider. This is what I'm drawing. Okay, remember, this is what I want. The green area is what I want. This is the green section. Okay, that's A. This is what I want. What I don't know is I don't know what the angle is, but I know that that's cos of A is what I want. Okay, and I want to know what this angle is equal to. That's the goal. Okay, now if I can manipulate what they've given me, so the only thing they've given me is this. They've only told me that negative sine of 5 pi on 14 is what I want the cos of theta is. Now remember, I just said cos, I've just let it equal to A. Okay, so I've just said cos of theta equals to A, because that's what I said. I said I want this horizontal length over here. That's what I wanted, right? So if A equals cos theta, essentially what I'm saying is I want negative sine of 5 pi on 14. That's the only thing they've given me. Negative sine of 5 pi on 14. The problem is, in terms of exact values, I don't know what sine of 5 pi on 14 is, and you don't really need to know. Okay, you just need to know the positioning, because remember, the goal wasn't to find A, the goal was to find theta. So here we go. Let's use what they've given us. So I'm going to use what they've given us, and my goal is to replicate the problem. So here we go. What do I have? What have they given me? They've given me sine of 5 pi on 14. So I know there's a negative there, but we're going to ignore the negative for now, because the negatives just makes it. We want to know the value. That's what we want to know. We want to know what A represents. And so here we go. Let's have a look at this. If I drew a unit circle again, they told me that sine of 5 pi on 14. Now 5 pi on 14 is less than pi, right? And less than pi, it could be here. I don't know where it is, but I'm just going to say there. I'm going to say from here to here is 5 pi on 14. Okay, sine is what they're asking. They say, I want at this particular point, when it's 5 pi and 14 distance, I want to find the height, which is sine. Okay, so they're telling me this is my sine value. This one that I'm coloring in green as well. Okay, so when it's 5 pi on 18, 5 pi on 14, then I've got this value here. This value here. Okay, and what they wanted this to be, okay, if that's sine, that's a positive. Let's call this, I'll call it a different letter. I'll call it, let's call it B, okay? Then what I wanted was, if I rearrange this, A equals to negative of B, okay? Because sine of 5 pi and 14, this is B, this is sine. This is your sine, Okay, sin, don't forget, sine is your y value. So b represents the y values, the height of this triangle. Now, the only way to have negative b is that you can either have it down here. So this is negative b, or it could be over here where you have negative b. Now, the only way to get negative b like that is you can either have this point where this angle is again 5 pi on 14, or you can have it over here where this is 5 pi on 14 as well, and you get negative b. Now, out of those two regions, which one do I want? You see, I want it between pi to 3 pi on 2. So I know it has to be in this region here. This is the region that I want. Now, I've called it negative b. Now, remember, our goal is that we want a. Now, where was a again? I'm going to highlight again. A was here. This is where a was. Remember, we just said before that this is a. Yeah, that's what I did here. I just replaced, that's your a value. Yeah? So this a, I want to replicate the triangle that I've given. I've been given this triangle. Remember, it was 5 pi on 14, and I've been given b. True, that's all they've given me. I'm going to try to manipulate this b, because I want this b, which I'm coloring red now, to equal a, which means I want it to be a horizontal length. Now, how can I rotate this triangle so that I can get that triangle? Now, what you can see is this is what I did in the solutions. I drew it again, and I said the only way to get b to equal to a, and it will be in this region as well, okay, in this region, was if I drew it like this. If this was negative b, okay, now, in order to get that, and remember, what angle did I want? I want, at this point, now, I can, instead of getting it inside, I can get it here. I can say this is 5 pi on 14, and that's negative b there. Can you see how I'm just rotating this shape here? Remember, this is your triangle, 5 pi on 14, and this was b. Now, the only way to rotate it is if I rotate it this way, you'll see that I'll get this shape. So if you can sort of picture rotating triangles, this is still b here, but the only way to get b on the other side is if I flip it. So I flip it, and this is now 5 pi on 14, and this is b. Now, if that's b, see, what I want you to be able to picture is if this is b up here, which is exactly what I have here. That's essentially what I have. A, this negative b is now equal to a. So, looking at this triangle here, this is what I have. I finally got my negative b that I wanted. I'm going to color in green. So, this is my negative b. That's the negative b, and that's exactly the same position as my a over here. Okay? So, now that they're exactly the same, what was my goal again? What was I trying to find? I was trying to find the angle. I want to know this angle. Now, the cool thing is, I know here was 3 pi and 2. Remember, the limit was from pi to 3 pi and 2. And I know this is 5 pi on 14. So if 3 pi and 2, if I just subtract by 5 pi and 14, I should get the leftover angle. Because remember, the angle from here all the way around is 3 pi and 2. But if I just lose 5 pi and 14, I should get the angle I want. So therefore, that's why I wrote in my solutions, theta is equal to 3 pi on 2 minus 5 pi on 14. And that gives you 21 pi on 14, take away 5 pi on 14. And what does that give you? That's 3 on 2. Oh, sorry. So 21 take away 5, 16 pi on 14, which is the same thing as saying 8 pi on 7. Okay, so the angle theta has to be 8 pi on 7. I think my OneNote just died. Okay, here we go. Oh, I can't seem to move my... What's going on? Oh. I can't seem to move my screen. Anyways, that's how I got the answer for this solution. Okay? So try to look at my diagram again. Remember, the goal was just to replicate what they've given me. Okay, so remember, just going quickly summarizing what I had. I wanted to find an angle somewhere between pi and 3 pi and 2. I wanted to make sure at this angle, theta, I have a cos, which is what I'm coloring in right now. I'm going to highlight it as well. Cos is this horizontal length there. I wanted that cos to equal to, so I want that length to equal to what they've given me. And what they gave me was that they said sine, negative sine of 5 pi on 14. But you see, I know that sine of pi on 14, 5 pi on 14, if this is 5 pi on 14, see, this is when sine is positive. But if I want negative, well, the only way to get negative, it was either down here or it was on that side. So these were the only 2 points. But I knew I wanted over here. But the problem is that this triangle has 5 pi and 14 here, and it makes sine this side. But that's not where I wanted it. So remember, I didn't want sine on this side. I wanted sine over here. So I had to rearrange the triangle, and I drew it like this instead. I said, what if I wanted that length, what if I drew it like this way? And this is 5 pi on 14. Therefore, this is my b. If that's my negative b, then negative b is the same length as this one, and hence it equals to a. And therefore, you know, you can do 3 pi and 2 from here, and then you minus 5 pi and 14. That's essentially what I did. Okay, just in case you're still feeling a bit uncomfortable about it, let's do another example. Let's do question 10 with the same ideology. Now, I'm just gonna copy paste this section. Question 10. All right, let's try this. Well, okay, let's have a look. Same drill again. Look at what position do they want my angle to be. So I've got my circle. I want my angle to be between pi and 3 pi and 2. So as you can see there. And I want theta. So it's from here to here. That's theta. That's what I want, right? But what do I want of theta specific, or what have they given me? They said sine of theta. So where's sine of theta? Sine of theta is, and I'm going to color it here. So at this point, sine of theta represents the y values. Okay, so this is what I want. That's the point I want. I'm going to call this A again. So that's A. Okay. In terms of my triangle, I'm going to highlight again. What triangle do I have? I've got this triangle here. And I'm gonna draw that out in black so you can see. I'm just gonna draw that section out, and it looks like this. Okay, it looks like this, and this is the A. That's what I want. So I need A on the y-axis. That's what I need. I need this point. I need A. Okay, so that's what I need. This triangle on the left is what I need. What have they given me? They've given me negative cos of pi on 8. Again, I don't know what cos of pi on 8 is. I'm going to draw it. So pi on 8, this could be pi on 8. Okay, so that could be pi on 8. I'm going to say from here to here is pi on 8. Cos, at this point, the triangle is drawn there. And what is representing cos? It's this horizontal length, okay, which I'm going to call B. Okay, so that's my B. That's my triangle. I'll draw that triangle a bit bigger so you can see. Okay, when it's pi on 8, then B is what I have. So that's the triangle I have. Now, what was my goal again? I wanted B to be negative. Notice there's a negative there. Now, where would B be negative? The only region that would be negative is on this side here. And so therefore, you got 2 points. You can either be here or you can be here. That's the only time you're going to have negative B, right? But out of all those regions there, the point that I want was between pi and 3 pi and 2. So I know it can't be the one on the top. It has to be on the bottom. Now, in order to get this point, you see, and get that negative B, this is the triangle I'm working with. But then if I do this, B, negative B, okay, if this is pi on 8, negative B is on the x-axis. But I don't want it on the x-axis. Remember, what I wanted was I wanted to be on the y-axis. So, how can I rotate my triangle so that b, instead of being on the x-axis, I have it in the y-axis, where it's negative b. Okay, so this is what I want. I'm going to draw exactly what I want. I want to have negative b down here. That's what I need. Negative b to be there. Okay, so let's say it stops here. So at this point, I want that to be negative b. Now remember, b is the adjacent of this triangle. Now the only way for b to be an adjacent is if I have the angle here, which is pi on 8. Yeah, so if you actually label this triangle, see if I label that triangle, if I draw it a bit bigger, see if this is pi on 8, well then negative b is the adjacent. This is the hypotenuse, this is your opposite. So this is the adjacent side, right? This is the adjacent side, this is the opposite, this is hypotenuse. So I finally got negative b on the vertical axis, which is here. And what am I trying to find again? So going back to the point, I wanted theta, which is from here to here. Right? But I know that up to here is 3 pi and 2. So I know that if I got 3 pi and 2 and I just subtract by pi and 8, I should get my solution. So theta should equal to 3 pi on 2 minus pi on 8 times it by 4. So that's 12 pi on 8 minus pi on 8. And the answer is 11 pi on 8. Okay, and that's what theta should be. There you go. Hopefully that kind of feels a bit easier to understand. I'm going to leave it there. And actually, no, you know what? There's one more example I forgot to mention about as well. So hopefully now you should be able to do question 11, or at least look at my solutions and go, oh, yep, it kind of makes sense now. Question 12. Question 12 is a nice one because it gets you to think about your trig ratios. So I'm going to show you. Trig ratios. Here we go. So in this particular problem, it's in 2 revision sheets that has this problem. The only thing I've given you is sine of an angle. So sine of x is equal to 3/4, or 3/4 there. Now what you need to understand is sine of x is actually equal to opposite of a hypotenuse. Yeah, going back to year 9. And since I said 3/4, what this implies is when you have like this is your x and y axis, when you make an angle of x, right, an angle of x, then the sine, which is the y value, we say this is 3/4, right? Or alternatively, another way of thinking about it is if you have this triangle and you have the angle x, then opposite, which is this side, this is 3, and hypotenuse is 4. That's why we can say the ratio of sine of x is equal to 3/4. Similarly with this one, you could say the radius is 1 because that's a unit circle, and it'll be 3/4 over 1 because it's the opposite, this is the hypotenuse, and it still equals to 3/4. Similarly, this is 3/4 too. Yeah? Now, the nice thing is if I know this is 3 and I know this is 4, then I should be able to find this one out because I can use Pythagoras' theorem. I can say, well, if this is Pythagoras' theorem, this is your C, this is your A, and this is your B. So apparently C squared equals to A squared plus B squared. And C, which is currently 4 squared, equals to 3 squared plus B squared. So 16 equals 9 plus B squared. 16 minus 9 is 7, B squared. So now that tells me B is equal to root 7. So what does that mean? It just means that this section right here, this length from here to here is now root 7. So if I draw my my triangle again, when this is x, this is 3, this is 4, and this is root 7. Now we said sine of x, which is opposite over hypotenuse, which is 3/4. Cool. But then that means now I can find out cos of x, because cos of x was adjacent over hypotenuse, which is root 7/4. And then if you want to find tan of x, well, tan of x is opposite over adjacent. So it would be 3/7. And there you go. That's how you would answer this question to find cos of x and tan of x. But remember, you wanted to find, well, they said sine is in between pi and 2 to pi, which I think my solutions might have been wrong here, actually. that means if it's in between pi and 2 to pi, then x will have to be in this region here. You still have the same triangle if that the whole thing here is x. Then what you got to know is in this region, sine is positive, so it'll still be 3 and 4. But cos, clearly the length has to be a negative root 7. So this should be negative root 7 on 4. And the tan is clearly a negative, so it's negative 3 on root 7. So I believe my answer is wrong in my solutions, which I got to go fix now, actually. So I'm going to go back, and I think the answers here should be negative and negative. Oh, it closed. Okay. Anyways, that should summarize any of the questions I thought was a bit tricky, and we were going to go through it on Wednesday, but I wasn't feeling too well on that day. So, but that's it. But look, even if you didn't understand, look, I'm not putting a lot of those questions in. My aim is for you to show me that you can solve equations and you can sketch equations and you know your exact values and symmetry properties. These are symmetry properties as well, but they require a bit of flexible thinking, and it is going to be in the SAC. But I'm not going to put a lot of it. It's like 1 or 2 marks in total. So if you get it, great. If you don't worry about it. Get more of your marks from the other type of questions, which is more important, being able to solve. Okay, because next year in your exam for year 12 methods, you know, the least you can do for circular functions is solve for x. And if you can do that, good. Okay. But anyways, I'm going to pause the video and I can upload it. Otherwise, you guys will be having a very late night, or at least you guys can cram it tomorrow if you're studying tomorrow. Okay.